Hello everyone. My name is Miguel. I'm from the group Budir, and we have with Nadia, Asif, Yana, and Chanda in the group. So our topic is universal decentralized identification service. First of all, I want to give a little description about our task. So we have to create a universal identification service, like which works without any third party, and it should be traceable, immutable, and it should be secure and decentralized, and of course it should be free access for users to join. And so in this slide you can see the background. Currently about 1 million people don't have any identity, proof of identity. And in addition, like many countries adopting their national identity system. So, as we know, what is identity? Like digital identity, like describes our personal data in a online system, and it's actually connected to our actual identity. So, and till now, we know the central and federated identification types. So what does it mean? Central means we have to create an account or sign in to each server, service or application separately. And federated means some third-party companies offer their function to sign into the service. For example, you can sign to some services by using Google, Facebook, or LinkedIn accounts. So what's the problem of using that two types of identification service? So first of all, in centralized, it's all of our data goes to that services database, and it's very vulnerable, and it's not secure, and it's not mature. So in the federated, it's much more secure compared to centralized, but third-party companies can track our data and without notifying us. So, and currently, especially in the Euro Union, there is a policy about GDPR, and it's like this kind of actions is not compliant with the GDPR rules. Yes, Nadia will explain our solution. Yeah.
So, in order to tackle the above problems, there is a new identity system that is the new term nowadays. It's self-sovereign identity. So this system basically gives control to the individual, to control their information, and there is no third party. And this identity system basically is managed by the decentralized system that ensures the security. So. Nowadays we have multiple use cases in real life. They cover the public transportation, accessing to health services, and accessing to educational services. And how does this self-SSI actually work? It includes three main components that are issuer, holder, and the verifier. So they communicate between each other, and they establish trust triangle. In this case, the holder is the simple user, or maybe one person who wants to get verified by some organization. For example, it might be some people who is searching for the job, and that person wants to get accepted by the workplace. In this case, verifier is the workplace who should accept the employee, but in order to accept the employee, it requires some kind of certificate or issued credential by the issuer. So it might be given by the some kind of educational center, for example. In this case, verifier will communicate with issuer and get the information from the issuer. Then user can be verified by the verifier. After proving that its identity is legit, identity is not fake, and it's correct. So next, Nadia will continue about the solution.
So for our solution architecture, we proposed the following architecture, whereby we have the service provider, the validator, and the holder. So how does it work? First, the holder will request our application to get his, to register his identity on the blockchain network. We use Ganache to build our blockchain network. And after making this request, the holder identity will be stored on a digital ledger, and before being added to the blockchain, the validator has to make sure to validate the identity of this user. Once it's validated, the validator can be a government agency. Once it's validated, it will be added to our blockchain network. Then we have the service provider. Let's say we have a request from the user to the service provider. The service provider, as Diana mentioned, can be the healthcare provider or the transportation system provider. So let's say the holder wants to buy bus tickets. What the service provider has to do has to access the blockchain network first to verify that the user is registered. Once the verification is done, if the user does not exist, it will reject the request. If the user exists, it will accept the request. Okay, this is just a flow diagram to give a more comprehensive explanation of how our system architecture works. So we have the holder. It initiates an identification request to our application. After initiating the identification request, the user information is added to a list of records. And then the validator has first to see if this user is a legitimate user. If no, it will reject this transaction. If it's a yes, it will add it to the blockchain. After that, we have the user will make a request to the service provider. The service provider has first to check if the user exists on our blockchain. If it exists, it will. If it does not exist, it will reject the request. If it exists, it will send a response to the user. Now, then we'll do.
So you see how we implemented SSI and what is the importance of SSI in the present scenario. But then there are challenges that we need to focus on. So the first challenge is interoperability issue. So what does it mean? So not everybody is used to blockchain. And then suppose I give the solution and then I ask them to use the blockchain and sign into different services. People will not do that. Still will have the conventional way of signing. So we have to, like, there will be different systems existing and we have to find a solution so that we are still in the market with other solutions, like using the conventional way. That's one of the challenges. The other is key management issue. So in blockchain, there is an address for each user and that's the key. And you need a wallet to store that key. And that's one of the challenges, I think, in SSI. So you have to keep that address safe so that you don't lose it and you have your identity safe. So that's one of the challenges. And the third is trust on blockchain. Still, many people will never trust on the system of blockchain and then they are not ready to come to this distributed peer-to-peer network. So it will take time, but then slowly people can come to this network and use SSI. But yeah, for now it is a challenge. So I'll move to the practical demonstration that we have implemented. So I've recorded a video for this. So how we are going to implement this. To generate a blockchain distributed network, we are using Ganache. So it provides Ethereum blockchain. And then we have 10 users and it has some currencies, 100 Ethereum currency as you can see. And we have two different applications and these applications I'm running on my localhost. So now let's see. So in this system there will be a verifier so that now people, it's easy to get on blockchain. You have a wallet, you get on blockchain. But then there should be a verifier so that he controls like who comes to the, who have access to that system. So suppose this user, he has this ID and he is the verifier. So that verifier is only allowed to see the details on the blockchain, like detail about each of the distributed network. So you can see if you log into the site using this account, he see this is the verifier, and you see his account is already verified. And as you see, these other users, they are on the blockchain network, but then they are not verified. So the third service, the third party service who wants to use this service, they don't still believe that this user is a verified user and they are genuine. They might join the network and then they might be faking their identity. So what's the job of verifier? They verify the identity of the other users on the blockchain. And this can be any government official who is using, like any government official can be verified. He goes, sees like who is in the network and he can verify them. So, and this is called a digital certificate. Like if there's a blockchain network, each blockchain network has a detail like about it, and then it is stored in the file, digital file that's on the blockchain. And this is what only verifier can see. And so I'll log in using so suppose a new user who is in the blockchain wants to get verified. So what he will do, he will create a smart contract on the blockchain and give his data to the digital certificate on the blockchain. And the verifier, he sees the data on the digital certificate, and then on the basis of criteria, maybe a government official who can back check like if that detail is correct, and he can verify that. So I'm just sending a smart contract using Remix Ethereum ID, and I'm using a wallet MetaMask for that to create a smart contract and send it to the blockchain. So now, so suppose a normal user logs into the blockchain system. He can't see the digital file. You can see he doesn't have access to the digital file which has the information. He can't do anything because there's still, he can be in the network. Only the verifier is allowed to see the digital file. And suppose now he sends the information which goes to the digital file, and then the verifier will finally verify this. So he will send these details like request for access, any name or anything, and he submits it. And this is the wallet that we use. And so now, as you can see, this detail is updated. The third user who sent their information is now on the digital file. And now, suppose this is the digital file. Now comes the main problem. Like there is a hotel booking site, a government passport department. They want to use SSI. So what they can do? They can have the access of the digital file on the blockchain. And suppose I'm a user and I want to log into the hotel system. So I'm not providing my email address, password, phone number, anything. I'm just providing my address of the blockchain. So since the third party has access to the digital file, he'll see if that user in the blockchain is in the blockchain and if that user is verified. So suppose suppose there's a third party service like booking ticket. Let's see. So I'll copy this address so I'm trying to log in with this system, but I cannot log in. Since I'm on the blockchain, but I'm not verified. I'm still not verified. And who can verify this? Just the verifier. So let's verify your detail and see if it is. So now the verifier has verified this user. And now when you try to log in, now this user can log into the system. Since that guy is verified on the blockchain by the verifier. So that's how. So the verifier can verify different user that's on the blockchain, and then for now we see that there are where this main implication of this SSI. So we see there are a lot of refugees in different countries, and the government doesn't want to give a permanent identity to them. So because maybe the issue is solved and they want to go back to their country. So what we can use this technology like SSI and give them identity. That's a temporary identity, and they can still use the services in your country. But if the problem is solved, they might go back to their country, and you are not giving a permanent identity. But there are human rights issues. if a refugee comes to your country, you have to provide all the services. And to provide the services, he needs identity. You can't give a permanent identity. So you give a temporary identity using blockchain, and then he can still use all the services, and you are not giving a permanent identity there. So it can solve this issue. Yeah. So this is the implication of this. And then for future scope, Nadia will.
For our future work, we are just proposing to provide some improvement to our architecture in order to provide more privacy, as well as tailored application to specific services. So in our previous architecture, we have the government agency or the validator have full access to the blockchain, which means it have access to the user information. In this case, when the holder make the request to add his information to the blockchain and it's added, he has the option to specify whether to share this information with the validator or no. And after that, how does the validator, if the validator does not know the information about the holder, how can it verify the identity of the user? The way we propose it for our future work is that the validator, if it gets a yes confirmation that the user exists on the blockchain, it sends a verification certificate. It signs a verification certificate with its private key and send it to the holder. And then the holder can use this verification certificate and send it to the service provider. And then the service provider, with the help of the public key of the validator, can verify if this user is legitimate. So the service provider, even the service provider, does not have access to the blockchain. Another reason why we propose this architecture is that the validator in this case can be any authority that controls service provision. Let's say for healthcare, the service provider can be the healthcare authority, and the healthcare authority can, for example, have if the user gives the grant to see his information, they can verify if the user have access to free healthcare services or has an insurance, and based on that, maybe send it to this information to the healthcare application to provide specific tailored services to the user. That's the end of our presentation. Thank you.
Do you have any comments?
This is a very interesting application. And we kind of need that. I mean, we're always authenticating ourselves and remembering passwords and forgetting them. And we need them.
So we're going to build that if data is going on, how they are using the data.
Yes.
Especially with the GDPR using Google and using Facebook, we're going to be same tools. Batteries, and then the service will have the GDPR information.
When you talk about blockchain, what kind of blockchains do you use? Or is it
For now, for the demo process, we have used Donation, and we have created 100 nodes, 10 nodes is provided, create 10 nodes, and then we go working on that. And then it's easy to implement our VM distribution. We just test it using Donation.
But you see that if you, right now you're using Budir.
Yeah, it's easy.
If you change the algorithm behind, does that affect the entire process, or do you see any impact or implications? Just your reflections on that.
So if you see the architecture is same, like it's blockchain, just if you change cryptocurrencies, maybe cryptocurrency is very different, but the architecture we have of the blockchain is same, like it's a distributed token. So I don't think there's a lot of change, but then if there's the same, we get the best thing is like there is a system, this SSI, and if any third-party service on it, we provide API. Like we don't have to change, and then if there's slight change, we can obviously change.
So basically, we have considered processes algorithms. Mainly, we wanted to investigate the utilization of the blockchain itself to provide
provide privacy. So we have not gone deep into this, let's say, the responsibilities and
Something that can be implemented the verification side.
So for now, we just show one verifier. But anybody can join on a blockchain. Like you have a wallet, you join it there. So there should be a verifier, not just one. There should be a group of verifier, a human verifier. Like you can fake your data, you can upload a fake document. You can also, who is the verifier? So like maybe a government official who knows, okay, this is a correct verifier. So not just one, we need a group of human verifier. Because anybody, even if you are on blockchain, you can see like your details, you can upload big details, and then you can log in on third-party service, and that's a easy problem. So we need that.
maybe for the future architecture, because before we have like the government agency that has access to, that already has access to the citizens, the information of the citizens is validated. In this case, the validator, maybe you can use some smart contracts in order to get some information from the user, and then based on this smart contract, we run a smart contract to this information to make the verification really strong.
Okay, thank you very much.